Hello, this is Sabbir. The topic of our discussion in this video is how to calculate the area under the curve and distance from a velocity function. Area is a measure of size of two-dimensional shape. For example, the area of square, the rectangle and square is given by base times height. Area of a triangle is given by base times height divided by 2, and the area of a circle is pi r square. So we have formula to calculate the area of these three basic shapes. But question is that how to calculate the area of bit more complicated shape. For example, if we have this shape, which is a given by this curve, if we would ask to calculate the area of this shape starting from 0 to 4, and how to calculate the area of such shape. The technique which calculates the area of the shape is known as a Riemann sums, because none of these above three basic does not look like the above three basic shapes. So we will use a technique, a procedure which is known as a Riemann integration or Riemann sum. So how we will calculate the area of this shape? The first we will do that we will divide these shapes into 3 or 4 pieces. So I will divide this shape into 4 pieces first. 1 and 4. So I divide the shape into 4 pieces, and from these 4 pieces I will draw rectangles. So I draw these rectangles, so I can say that the area of under this curve can be approximated by the total area of these rectangles. So if I calculate the area of each rectangle and add them up, that will be the area, some approximation of the area under the curve. It will not be exact, but it will be approximate. So how to calculate the, so let's suppose this first shape is R1, R2, R3, and then R4. So our total area will be R1, R2, R3 plus R4. Let's pick one rectangle and see that how we can calculate the area of this shape. So you can see this length, since the total length was 0 to 4 and divide the 4 units, so this length of this piece is 1 unit, which is also sometimes we call delta x. So our delta x is 1 unit. And now the question is, what will be the height of this rectangles? The height of the rectangle is basically this height, or I can say, if I calculate, so this is a 0.3, this is 2 and 1. If I calculate the function at 3, that gives me the y value, and y value is the height of our rectangle. So the height of the rectangle is f3. So the area of R1 will be delta x, which is a 1 time f evaluated at 3. And similarly, R2, if we see that this length is 1 unit, but the height is, we can get the height of this rectangle so by plugging the x value into the function. So y value is the height of that rectangle. So it will be f evaluated at 2. And again, the width of this rectangle is same, but the height is f evaluated at 1. And for this rectangle, the height is again f evaluated at 0. So 1 multiply f evaluated at 0. So if I plug 3 into the function, what is my function? Function is a 1 plus x square. So I will get 1 times 1 plus x square, which is a 10. So the area of my first rectangle is 10. What is the area of my second rectangle? If I plug 2 here, so basically this was 10, this height. And if I plug 2 here, 4, that will give me 5. And if I plug 1 here, that will give me 2. And if I plug 0, that will give me 1. So this is the area of my first rectangle. This is the area of my second. This is the third, and this is the fourth, the area of that. So I can say the area of this one is a 10. Area of this one is 5. Area of this one is 2. And the area of this one is a 1. And then I will add them all. So when I add them all, what will be my total area or this approximation? This is 10, 5, 7, 18. So that's total my area is 18. So this is basically calculating the area when your approximation is under. This technique is also called the left hand point. As you can see that we start from 0 and we plug until 3. So all we are doing is here, if I simplify this one a bit more, if I simplify this step, this will be 1 because we can pull out 1. So 1 multiply f evaluated at 0, f evaluated at 1, f evaluated at 2, and f evaluated at 3. So all you have to do is you have to multiply delta x, what is the width of each interval, with the sum of the function evaluated at 0, 1, 2, and 3. Because we choose the left end point, so 0, 1, 2, 3, and we did not choose the right end point. So this technique is called left end point. Let's look at the one more way of calculating this area. Let me clear the screen first. So let's suppose I have the same function and I will again divide into 4 pieces. 1, 2, 4. This time I draw the rectangles over the graph of the function rather than under. Last time we draw the under the graph, but this time over the graph. This will be a 3, this will be a 2, this will be a 1. And in that case, what will be the total area of the function? So again, the total area will be the area of each individual rectangle. So what is the area of this rectangle now? The width is again 1 unit, but height of the rectangle is the y value of the function at 4. And the area of the second piece is a 1 time what is the height of the rectangle at evaluated, say f3. And similarly, this one will be evaluated at 2. So f2 multiplied by 1, and then f1, the last one is multiplied by 1. So I can pull out 1. So you see the f4 plus f3 plus f2 plus f1. And if we calculate these values, we're gonna get 16, 17 plus 10 plus 5 and plus 1. So that's give you 17. So that's a 4 plus 5. So 4, 3, 2, 1. 1 gives you 2. Sorry. That gives you 2. That gives you 5. That's a 9 plus 10. Okay. So that's giving you 17. So 27. 27 plus 5 is 32, 34. So the area is 34. So this is the overestimate because we calculate the area over the shape of the curve, and so we got 34 compared to last time we got 18. Let's this is called a right endpoint. So you can see that I'm choosing the right point to calculate the area of this. So I choose the right point to calculate the height of this one. Here I choose the right endpoint to find the height of the rectangle, and here also use the right endpoint. So there is one more technique, the one more way we can also calculate the area, same area. So let's draw one more way of calculating the area. So this is the same shape. Again, I will divide into 4 pieces. This times we will draw little over, little under. So not too much over, not too much under the graph of the curve. So this time total area will be the area of this piece. So again, this is a 4, 3, 2, 1. This time the length is again same, the width of the interval is same, but the length of the height of this rectangle is now evaluated at the midpoint, so which is a 3.5 here. So you take the midpoint and you plug and you calculate the y value, and this is basically is equal to the height of it. So f is evaluated at 3.5. For this one, f is evaluated at 2.5. So 1 time f 2.5, and here is basically 1.5. So f evaluated at 1.5, and here is 0.5. So f 1 time, so 1 time as a 0.5. So you will get 1 plus 0.5 square, 1 plus 0.25 square, 1 plus 0.1 square, and 1 plus 0.5 square of that. And that gives you 25 total. So this is called the midpoint method. Midpoint gives you more close to the exact area than the left and right end point. Left end point is basically just underestimate or right overestimate, and the midpoint is neither underestimate, never overestimate. It's get more a little better than the exact area of the graph. Here I have one more example where you calculate the area under the graph of the function y is equal to x square, which is this function from 1 to 4. This time we divide the rectangle into 6 segments. So if you have if you start from point 1 and the end point is a 4, how you basically divide into 6 segments. The first you have to calculate the delta x. Delta x is a 4 minus 1, the difference of endpoint divided by n, number of values you want to divide. So this will be a 3 over 6, which is equal to 1/2. So once you have 1/2, the next point will be 1 plus 1/2 is 1.5. So then if you add 1/2 again 1.5, that will be 2. And if you add 1/2, it will be 2.5, and this will be a 3.5. So these you get the division of your shape, So basically, if you see that, it's like here. So these are the six division of your this shape. Again, you can start underestimating or overestimating. It depends on what is you when ask you to do. So if you are underestimating, you will choose the left end point. It means you're going to choose only this point. So what will be the area according to the previous calculation. The area will be delta x, which is a 1/2, and then evaluated, f evaluated at 1, f evaluated as 1.5, plus f evaluated at 2, plus f evaluated at 2.5, and plus f evaluated at 3.5. This will be your left endpoint. What will be right endpoint? Right endpoint will be 1/2. This times we will only calculate the right and we will leave the left endpoint. So f evaluated 1.5, f evaluated at 2, and f evaluated at 2.5, f evaluated 3.5, and we will add the right endpoint 4. So these will be, when you plug that into your function and you can calculate, these will be the underestimation and overestimation. Here I have the overestimation. First I calculate, which is the right endpoint. As you see that I calculate these endpoint plug into the function, and then I multiply by delta x and I add them. The total area I have the approximately 24.87. Underestimation is, here I start from 1 and end up at 3.5. I did not include the right endpoint, and then I plug that into the function and then multiply by the delta x. Since the delta x is 1/2, so I just multiply 1/2 to each of them, and then I add. So you can see this is underestimation, which is a 17.375. And this is the midpoint estimation when I calculate the midpoint of each subinterval, which is midpoint of the 1 and 1.5 is 1.25. So again, the midpoint of each interval are here calculated. I evaluated the function, then multiply by delta x, and then I add them all. So this is the midpoint estimation of. Let's compare our result. You see the overestimation. The right endpoint is overestimation, which is a too high. Underestimation is too low. The closest estimations you can see from the graph and also the table is a 20.9375, which is the closest, but it's still not exact area of the graph. Here I have one quiz which you can practice. In this cases, you have to divide the interval into 4 pieces. The interval is starting from 2 to 4 and function is a 1/x. Yeah, you would need a calculator to have that handy in your nearby before you start this question. So please pause the videos and leave your answer in the link above. Let's see that how we can calculate the total area from this technique. And let's analyze that how the Riemann sums are will get the better approximation if we divide the region into more number of pieces. So here I take the midpoint estimations and divide the region into 5 shape, the 5 pieces, and then I see that this is my some I'm losing, at some point I'm losing and some I'm gaining. So I'm still not whether it's exact or not. If I divide into 10 pieces and I can see that the portion I was losing or portion I was gaining is now the less. So it means the error is less when if I divide into more number of pieces. N is equal to 15 is get really better. N is equal to 20. If I divide into 20 pieces, the error is getting smaller. N is equal to 25. You can almost see that I have very tiny bit of error because I'm gaining and losing very little. And at 35, almost like with the human eyes, you can't detect that this is the area approximated by these 30 rectangles, almost same as the area is under the graph of this shape. So we can conclude that the area is this sum, because this is, if you pick the each rectangle, if I see that if I pick one rectangle, this is my delta x, which is equal to b minus a divided by n. And the height of the rectangle is always I calculate the y value, whatever the xi I pick. So I pick the midpoint or I pick the right hand point. So this is my xi. So depending on that, and this is the limit. So limit will be very helpful to calculate the total area of the graph. So you can use left midpoint, right midpoint, or the midpoint, and when you divide into an infinite number of pieces and takes the n goes to infinity, the area will be close to the exact area. Let's practice with this example. So in this examples, we have the A is equal to 0, B is equal to 1. This implies your delta x will be 1 minus 0 divided by n, because I'm dividing n number of pieces, so 1 over n. So it means if you are starting from 0, your first interval is 1 over n, and if you want to do 1 over 10, second interval will be 1 over 2, and so on. So on. So as you can see, the right end point is the right point is 1 over n, 2 over n, and so I can see if I choose the right end point of the each rectangles, so my right end point of xi will be I divided by n, where I vary from 1, 2, 3, so on up to n, because when I will go to n over n, this will give me 1. So I choose xi, my right hand point. You can choose also the midpoint, which will be 1 over 2n. So, but I think for me, the right hand point will work as well. So then I will calculate, because what is my total area? Total area is the limit n approaches to infinity, summation I vary from 1 to n, f xi delta x. So this implies the limit n approaches to infinity, summation I vary from 1 to n, fxi. So what is my x? Is it x square? My xi is I over n. So xi is I over n. So then the square of that, delta x is 1 over n. So if I simplify, this will be limit n approaches to infinity, and this is a summation is I vary from 1 to n, I square divided by n square times 1 over n. Since n is independent of the summation, I can pull it out. Limit n approaches to infinity. So this is a 1 over n cubed, and the summation is n vary from 1 to I vary from 1 to n I square. This is the sum of square, which we know the formula for the sum of square is, so 1 over n cubed. The formula for that summation is I n is n plus 1 to n plus 1 divided by 6. So because this is like, if you simplify, this one is, if you expand, this one is a 1 square plus 2 square plus 3 square plus n square. The sum of the first n natural number is n plus 1 to n plus 1 divided by 6. Now, if you calculate this limit n approaches to infinity, you have n cubed. I'm going to expand the top, and you have 2n cubed plus, let me expand to here, n square plus n times 2n plus 1, which will give you 2n cubed, 2n cubed plus 3n square 3n square multiplied to that and plus n divided by 6. So the limit of this will be 2 6 n cube. So 2 over 6, which is equal to 1/3. So the exact area under the graph of this function is 1/3 by using the Riemann sum. Now let's see how to calculate the distance by using this area under the graph terminology. So we have the velocity of the function. Let's consider an example. So let's suppose the velocity of a car is a 60 mile per hour. And then what will be the total distance? The total distance covered by the car in 3 hours. So the total distance covered by the car in 3 hours will be 60 multiplied by 3, which is equal to 180 kilometer mile. So now let's look into a different way. If I graph the velocity function, so the graph of the velocity function is a constant, is a 60, and I have 3. This is my time. This is the velocity. And you see that the area under the graph of the velocity curve is what? This is a 3 unit, and this is a 60 because this is a height is a 60. The graph is constant. So the area of is a 60 times 3, which is equal to 101. So this we can conclude here, basically the area under the velocity curve is equal to the displacement of the object. So here I can say here also, for example, if your velocity v of t is a constant, you can see the area under this curve is a v0 times b minus a, which is also the displacement of the function, the displacement of the object um, from traveling from t is equal to a to t is equal to b. So the displacement is equal to area under the graph of the velocity. So area under the velocity curve gives you the displacement, and we know that if even the car has a weird velocities going up and down, so we still can calculate the area by using the Riemann sum. So this has a really nice applications of calculating the total distance covered by a car which does not have a constant velocity. Here we look at that example. So let's suppose the acceleration of the car is 1 mile per second. So a of t is given, this is a constant 1 mile per second. So if we can calculate first what is the velocity of this curve, the v of t basically will be the antiderivative. This function is going to be a t plus c, but the car is starting from rest. So velocity will be 0 when time is 0. So it means c is 0. So that gives me the velocity v of t is just simply v of t. And then the displacement, so it will be, then the displacement by that object will be just area under that curve. So this is a 10, this is also a 10. So it's gonna be a 1/2 10 times 10, which is equal to 50. So that is the displacement of the object starting from t is equal to 0 to t is equal to 10, because it's just simply the area under the graph of that curve. Here I have another quiz problem for you to practice. pause the video for 1 and 2 minutes, and once you complete the problems, you can leave your answer in the link above. Here I have some optional topics which we used in this lecture also. How to, what is the sum of the first n natural number? This is n plus 1 divided by 2. What is the sum of the formula for the sum of the square, which is n plus 1, 2n plus 1 divided by 6, which I used in one of the examples in my video, and also for the sum of cube. These are hard to memorize, but you don't really have to memorize these formula if you know that how you can get these formula. So I have a nice proof from the first and the third one, which I will show you. It's just gonna be the proof by animation. So since the area of the left region is equal to the area of the right region, the area of the left region is sum of first n natural number. The area of the right region is n plus 1. So that twice the area you will divide the 2 over and you get the formula. The cube one is more interested. So this is the cube, this is the 1, this is the 2, and the 9, and so on. So as you can see that if you basically unravel the cubes and put them or line them on the ground, you can prove this formula on its more geometrical and object way. This is all I have in this video for now. If you like the video, subscribe my channel and hit the bell button so you can get the next video. I will see you in the next video. Bye for now.